Hello everyone. Good evening. Okay. Scaling beyond autoscaling. A quick round of a small question, quick show of hands. How many of you have been running Kubernetes clusters in production for 3 years or so? Okay. Cool. Nice. Less than 3, 2. Okay. Less than 2, 1. Okay. Less than 1. Okay, cool. Nice. Awesome. I'm excited. So, how we broke or rather grew our Kubernetes clusters. Uh, who are we? I'm Bhavin. I work as a staff SRE at InfraCloud.
Hello all, I am Ruturaj Kadikar, working as a senior SRE at InfraCloud.
So we both have been Kubernetes since 2018 or so. Before that as well, but more or less we have been doing it since 2018. We have been helping enterprises adopt Kubernetes and cloud native technologies. And we both like music, IEMs, guitar, flute, you ask. So it's a story time.
Yeah. So let's start with the story. So we plan to move to cloud native. Okay. Accordingly, we plan to adopt Kubernetes. We migrated our applications from VM to Kubernetes. Migrated all the applications, and after migration, like it was a decent cluster of 20 to 25 nodes. And on one fine day, we got to know that a prospective client is very interested in the product and is going to acquire us. Now that was a great news because we have a business growth. But with this business growth, we have a large number of traffic coming to our clusters. Accordingly, we have large number of infrastructure, large number of pods, everything. So my manager came to me and asked, like, are we ready for such a scaling? And I said, yeah, we have autoscaling. So we have already provided cluster autoscaler, node autoscaling. We have HPA for pod autoscaling. But actually, it was not really the autoscaling. So what happened next as the cluster grew? So coming back to our discussion. So we had autoscaling, but we realized that it is not really going to help us. So what happened? As we grew, there were number of issues, errors started to pop up. We had to deal with number of things. There were number of breakdowns, nightmares. So at that time, we got to know that the true scaling is not just growing, it is growing without breaking. Okay.
So this is the whole presentation. It's going to be our journey from 25 nodes to 250, right? And coincidentally, around this month, we have completed 5 years of the initial cluster we created. So when we realized that we have to create slides and present this, we definitely realized this is a vast topic and not something you can cover in 30 to 35 minutes. So what we are going to do? We are going to cover stories and experiences because we think that's what you will learn more from. A couple of practices to follow. And a lot of these are based on EKS because that's what we were using. But we have made sure everything we talk about is generic. So it will apply to every provider or your own cluster. So before we go to beyond autoscaling, let's talk a bit about conventional autoscaling. That's what we do, right? So on the image, you can see there is a bucket and around 80%, if there is more water, it will flow to another side bucket, right? That's what we do when we want to scale our applications. We usually increase the number of replicas. And that's what we saw. It's a horizontal pod autoscaling. Basically, we add more pods when we need more replicas, basically. Or there is a lot of traffic, or the CPU is around some 80%, 40, 50, whatever. Similarly, there is something called vertical pod autoscaling. That basically means instead of increasing the number of replicas, what you do, whatever you have allocated to a pod, you just increases. So instead of going horizontal, you go vertical. And obviously, if you go on increasing pods, you also need nodes which can host more pods, right? So they need more space. And that's where tools like Cluster Autoscaler, Carpenter come into picture. So that's what we do, right? Usually we think this is good enough, and it's a good start, always. So what happened next? What happens next usually?
So we generally have autoscaling, we have monitoring to look at it, everything is going fine. But the very first hit which we got, imagine that you are monitoring your system and that only breaks, okay? So how are you going to monitor? Like, it is the first hit which we got. So the glass through which we look, that only breaks. So the Prometheus, okay, of course. So just I'll be sharing the story of our Prometheus and how we tamed the mighty Prometheus, okay? So initially when the cluster grew, we started getting out of memory issues for our Prometheus pods. They were going into crash. Obviously, the first instinct was increasing the resources. So we started with a decent like 15 to 20 GB of memory. So we increased to 25 to 30, 40, 50. Just imagine at one particular point, we crossed 90 GBs. At that time, we actually panicked. So this is not the way we are going to work in production, right? So increasing the memory is not just enough. We have to do something. Then we take a step back. We went into the basics of Prometheus, and we understood how the wall is actually operating. So for those who don't know, it is write ahead logs which Prometheus uses. You can just imagine as packaging some objects into boxes, labeling them and creating a catalog. Okay, in this box, these so many objects are there. So accordingly, Prometheus packages all the samples into chunks, and accordingly it creates the val. Then we understood cardinality. Okay, for again, those who don't know, it is number of unique labels. So let's say you have a pod, it depends to one of the applications. So application A will be the label. It is running on one particular host. That is one label. You can have environment, something. So the number of labels increases, your visualization will also increase. Okay, you can pinpoint to that particular resource. Okay, this is from here and here. But as the labels increases, so the time series and so the cardinality, which is very harmful for Prometheus because it increases the in-memory processing. So then we again went with reconfigurations, samples, ingestion, retention time, wall compression, everything we reconfigured. We filtered the labels which were necessary. We filtered the metrics which were necessary. And yeah, that at that particular point, still we had some optimized Prometheus, but we sort of, okay, still there is in-memory processing. We can use long-term storage and reduce the in-memory processing. So we introduced Thanos. We got some relief, but then came, as usual, everybody introduces Istio. So again, everything came down because envoy metrics are very, it provides high cardinality metrics. So the memory processing and all of the Prometheus increased, but this time we were prepared what we have to do. So you can't deny all the envoy metrics, also you need visibility. So what we did was, we did automation. Whenever there was Istio upgrade, we want to see how many workloads are upgraded to newer version and all. For that particular duration, we used to enable the envoy metrics required. And then we used to remove them. So that there was automation for them. And that's how we stabilize our Prometheus. So this is just a brief glance what we can do: scraping frequency, samples ingested, in-memory processing, cardinality, val, and long-term storage. Okay, but it is not just a single piece for observability. Okay, there are many other things for observability. Okay, so scaling Prometheus isn't about adding resources. It should be fine-tuned to balance the performance and stability. Again, yeah. So what is beyond Prometheus, what we did? Okay, now for logs. Okay, one fine story which we had was, as the traffic grew, Istio was having, all the logs of the Istio was processed via Fluent Bit, and it was passed to Elasticsearch. There was one issue, an application team was tracking one issue, and they were not able to find a particular log in the Istio. at that particular point, we saw that, okay, FluentBit is operating at such large speed, but not all the logs are getting stored. So then we went ahead, we look into FluentBit. There are parameters like queue length, queue size, memory buffers limit. So you can use those parameters, tune it accordingly, and you can optimize the FluentBit also. Then comes scaling agents. By default, we directly deploy the scaling agents like metric servers, okay? Your exporters, agents like CloudWatch agents and all. So those also we need to keep a track. So one such incident was our CloudWatch agent was actually going out of memory, and that created a false alarm. So just to keep a tab on that too. IAC for observability, we know that, okay, there should be IAC for everything. So, but what is the importance of that? Okay, again, you upgrade Prometheus, there might be changes in metrics, you get false alarms, or there can be an issue with application teams are monitoring and there is no graph on the dashboards because the backend of Prometheus has changed some metrics and all. So to get rid of these issues and to mitigate these issues very quickly, if you have everything, alerts and everything coded, you can quickly change that and get the things done. Additional steps, what we did and what you can do as a process is logging verbosity, maintain the verbosity wherever it is required, maintain a log life cycle, enterprise licensing. So whenever, if you are scaling your clusters, if you have enterprise licensing, just predict cost and billing accordingly. And if you are using Elasticsearch or Loki, just go with like correct balance of indexing, sharding. If you are using Loki, again, filters and labels come into picture to optimize the time series and the overall cardinality. So with this, we stabilize the observability. But again,
while we were busy with that, something else also happened along the way. We were hit by this, insufficient free addresses in the subnet. When we started actually, and there were already subnets created, and for compliance reasons, they were fixed, and we started using those for pods, right? And with these cloud providers, AWS, I think GK and AKS, Azure and Google Cloud also, your pods utilize the same addresses from the subnet. This is done because it is efficient for the pods to communicate with each other using the same network infra the provider has. And this is what we were invited with when we were doing upgrade. So we did an upgrade, a new machine came up, but then when pods were moving out, they failed because there was no way those new pods would get a new address, right? This is very simple to overlook, and I'm sure a lot of you might have faced this. So what you should do, or what you can do, if you are at some point, how you can solve this, right? Add secondary subnets. A lot of these cloud providers have introduced a way to add a secondary CIDR block so that you can get a lot of more IP addresses for your pods. That's the best solution I would suggest because it is again using your provider network infrastructure. Switch to some overlay network CNI, which will create overlay network of different IP address range on top of the provider network. This is an option, but I would say it is disruptive because it will change a lot of things for you. If you are on AWS, these are two parameters which you can tune on the CNI plugin. It tells CNI plugin how many IP addresses to reserve. Because when you start a new node, it will automatically reserve some IP addresses. And have an alert. That's the most important. Don't forget at all. Have an alert which tells you, okay, these percentage of IPs are available in your subnet, you should act on it. While this sounds good, I think we shouldn't forget our friend DNS. And sometimes it is DNS. So in Kubernetes, there is a service called core DNS, which takes care of all the DNS resolution inside the cluster. The way it works is, think of it as a proxy. Whenever a service wants to talk to some other service, there would be a address, right? all requests go to this core DNS. And if there is any external request like aws.com or something, that will also go via core DNS. And it sees, okay, this is not something I understand, it will go to an upstream DNS provider. So let's see how core DNS handles this scenario, right? Let's say I want to talk to aws.com. And the NX domain is the response which a DNS server will give to your application, basically. So what core DNS does, when you give it aws.com, you can see there is default.svc.cluster.local got appended to it. So this is called a search domain. Usually all of your pods will have 3 to 4 search domains, and it will go and append this search domain until it finds some resolution, right? It's not able to resolve. It will do svc.cluster.local, it will do cluster.local. It will also do an AWS internal DNS resolution. And at the end, it will see, okay, nothing is working, I'll just try as it is, right? Then it will work. But the problem with that is what we saw, a lot of our requests were getting timed out at the load balancer level. So users were doing some transaction, let's say the request came to the load balancer, it came to some service, it was trying to connect to some other service. But because core DNS was bombarded and overloaded with all these requests, right? It was getting NX domain again and again. So it was overloaded and the requests were taking a lot of time. By that time, the user who was coming via load balancer, they got timed out, which resulted in again a lot of retries, and that was like a cascading effect. So what do? There should be some solution, right? So there are ways to tune core DNS. This is a small snippet of a configuration which you can see. So instead of telling core DNS to append those search domains every time, you tell it that if there is one dot, just go and check if that DNS domain is available. If not, then it will search for those svc.cluster.local, all those combinations. That way you decrease all that NX domain responses. There are other ways to do this. You can enable caching in the core DNS so that every time it doesn't do same thing, right? Set n dots to 1, that's what we talked about. And there is a tool called cluster proportional autoscaler. I would suggest everyone try this, because if your cluster is scaling, you should scale your core DNS replicas as well. So those requests will get split across multiple core DNS instances. The result, you can see the NX domain response decreased drastically. So that was some relief for the core DNS. In addition to these, there are few more things. One more story I would like to cover is ingress controllers. So all of you might know, like there is Istio ingress controller, Nginx and all, right? These are the entry point to all of your services. And sometimes these become a single point of failure as well, even if you increase the number of replicas and all, right? The memory and CPU on these pods should also be tweaked according to the overall load. We have seen cases where even after adding multiple replicas, that didn't help, because the minimum required resources were huge for that particular ingress pod. So this is very important, and often we don't look at it because we think, okay, just increasing the replicas should be enough. You should choose right instance size. Often what we do as things grow, we just go on adding new nodes, right? That results in a lot of overhead, because node agents like node exporter and all, they get deployed first. That is waste of resources. And one more thing in terms of network is each type of instance has some amount of bandwidth allocated to it. So these providers, right, cloud providers will limit how much bandwidth each type of instance will get, what sort of network interface card it will have. So you should definitely test all the scenarios, high peak traffic with your instance sizes, and decide how big the instance should be. Similarly, there are OS parameters at Linux level, like open files, open sockets. You have to make sure you track those. There is another thing called connection track, contract. There is a table. If it overflows, a lot of requests will have to retry. So these kind of parameters you should look for and track them and then monitor them. So we have these parameters written down at the end. So don't worry about specifics right now.
Yeah, so we are scaling everything, but this confidence in infrastructure scaling come from systematically testing its limit. So you should test up to what traffic, up to what limits you are actually going. And for that, we can leverage some chaos testing or load testing accordingly. I would suggest you have a shift left approach right from scratch when you are actually building or you are deploying the application for the very first time. From the very first time itself, you include these kind of testings so that you are prone to failures and everything. Have a load test at every interval. Okay, whenever you are giving a new release or something, it will give you a good idea about up to what extent you can actually your infrastructure can survive. Then you have some performance test. So performance test can be both component and end-to-end. So for one microservice and complete chain of microservice, you can get to know what are the bottlenecks inside it, and accordingly have some chaos test, pod failures or something. So even though you have 30 replicas, but one pod failure can have cascaded effect. So you need to address this kind of issues right from scratch, have some shift left approach, and you can reinforce your infrastructure accordingly. So we have scaled everything. We are doing whatever we can to scale our things, but it is also important to have some guardrails so that anybody can doesn't have according to the mistakes or something, doesn't have any impact on that. So for this you should have proper guardrails. So as I mentioned, I have 30 replicas, but that doesn't mean that the application is resilient, or there cannot be an issue in any catastrophe or during upgrades. So have pod disruption budgets properly set according to your applications with proper testing. Give a proper percentage or number accordingly. You can have a noisy neighbor kind of situation, okay, where one application is growing and it may have effect on another application on the same node or something. So have some limit ranges, resource quotas, and if the pods are very critical, proper node affinities and taints and tolerations, use that. Use some policy gating like opaque, Iverno or something. So people used to, if you have a multi-tenant infrastructure, people give you max replicas like 30, 40, 50, whatever it may be, but you put those guardrails to that max limit. These kind of issues also we have faced. So yeah, we have put guardrails also now. Yeah, but still we are just reaching the starting line. So scaling the infrastructure, everything is okay, but we have also want to maintain it. We have to do, for a very large cluster, you have to be very cautious around cluster upgrades also. So with newer versions, there are many changes, API changes and everything. So have some pre-upgrade checks, use some tools like Pluto or something which will give you correct what changes are there and everything. Remediate those. Then we have a normal flow of upgrading the control plane, add-ons, worker nodes, and have post-upgrade checks. So one story which I want to share is, as Bhavin mentioned, we had IP crunch, right? We introduced secondary CIDR, but again, secondary CIDR is a very large change. You have to change security groups, NACLs, everything. So ensuring that particular kind of SLA and everything without breaking anything, we introduced Kubernetes, which was synthetic monitoring. We once every node group was upgrading, we use Kubernetes to test all the endpoints which are there connecting properly and all, and then we completed the upgrade. So just wanted to share that you have to be very careful with the upgrades. Yeah.
And like we said, right, there is more, and we just touch based upon observability and network. So there are many things, and this is just a beginning, like we said. Each thing in itself is a talk. So these are the couple of things we talked about, and this is what we are calling scaling blueprint. Yeah, you can take a photo, or we have slides link in the next slide. So these are the tools, some parameters to look for, and things to consider. Yeah, this is the slides link. Would be, yeah, you can scan it. And time for questions if people have questions. We have, I think, 5 minutes. Yeah. Okay. The question is, during the scaling part, have you ever faced SNAT port exhaustion?
Not typically for SNET. We have so we actually got issues with networking, like as I mentioned, like for the OS. So open file descriptors, that limits we had to tune and increase. Yes.